Let's look at if-else day one notes. Int a plus equals 990. If a plus is greater than 100, that's true. It'll print out greater than 100, exclamation. If this ends up being false, if this ends up being false, it will skip this line, and this line will be executed right here. If else if, value is 58, answer is 0. If value is greater than 80, if that is true, then this line will be run and everything after that, all of this will be skipped. But it will print this one guaranteed. No matter what happens with the if else, this last line will be certainly run. Now, if this is false, it skips this line and then it checks the else. If value is greater than 60, now if that's true, this line will be performed and the rest of this will be ignored. Then if this is false, it skips it. This part will be run, and if that's true, then this will be run. Now if they're all false, then nothing will be run except for, again, this last line. So false, skip, false, skip, false, skip that. And if any of these are true, if that's false, it'll skip. If that's true, it'll do this one and then skip that part right there. It'll skip this else. And then, like I said, this last line is run no matter what. Logical operators, this is the or, this is the end. So int 1 is 6, 2 is 150. If 1 is greater than 3 or 2 is 200, then it will do the next line. Now, only one of those has to be true for an or. So 1 is greater than 3, it's 6. So this line will be printed. If 1 is less than or equal to 6 and 2 is less than 200, now with and, both of these have to be true for the whole thing to be true. 1 is 6 and 2 is less than 200. So that'll say both are true. Now if one of those were false, then this whole thing would be false. So we could make a note here that only one has to be true. Here, with an and, both have to be true. And here with an or, only one has to be true. Now if they're both false, that's false, 1 is not greater than 8, and 2 is not greater than 200. Both false, this will not be printed. This evaluates to false. 1 is less than or equal to 6, that's true, and 2 is greater than 200, that's false. So both have to be true. Since one of them is false, this whole thing evaluates to false. So this one evaluates to 1 is true. This evaluates to true. 1 is less than or equal to, it's equal to, and 2 is yes. This evaluates to true. This one, let's see, is one of them false here? Yeah, this one's false. Actually, they both happen to be false. So this evaluates to false because both of them are false. Only one of them had to be true. And then this one, 1 is equal to 6, that's true, but 2 is not greater than 200. So this evaluates to false as well. Nested if-else. Int num equals 5. If num is greater than 50, then it'll go to here. If num is greater than 60, if that's true, it'll go to this one. If that's true, it'll just print this line right here. But let's say this is true and this is false. Well, let's start with this. If this is false, it goes all the way down to this else right here, less than 50. If this is true, but this is false, it'll go down to this one right here. Then if both of them are true and this one is false, it'll do this else. So they kind of match up. This goes with that else, this if goes with that else, and this if goes with all the way down to that else down there at the bottom. Nested ifs. Int p equals 74. If p is greater than 30, that's actually true. It'll do this, but look at the braces. Not only will it do this line, it'll do this if again also. If that's true, it'll do that one. Now, what goes with that? Well, this if goes with that else. So this one does not have an else with it. So if that's true, it'll do all this. If that happens to be false, then it'll just do the else part right there. System out println hundreds digit is greater than 5, greater than 632. Here's a static method. If num divide by 100 mod 10 is greater than 5, if the hundreds digit is greater than 5, it'll return true, otherwise this returns false.